Hello everyone. Today we will discuss about traveling salesperson problem. And how to get solution for this problem using branch and bound design strategy. In the last video you already know that what is traveling salesperson problem, and finding the solution for this problem you are used one of the design strategy. What is that? Dynamic programming design strategy. In dynamic programming design strategy we need extra memory space. To get the solution for this problem, memory space required is exponential. It is very large here. So due to that reason, so now you are finding the solution for the same problem. Instead of using dynamic programming design strategy, now we are going to use this branch and bound design strategy here. So as you already know, the traveling salesperson problem is what? You have to find the shortest tour. So salesperson has to visit each city exactly once and before returning to the city where it started here. Okay. So now you have to find the shortest tour here. So for finding that, you represent all the cities and all the distances in the form of graph. That graph only you call as what? Weighted graph. In the weighted graph, vertices represent cities and edge weights specify the distance here. And here our aim is what? We have to find a shortest tour here. For finding the shortest tour in the branch and bound, you have to check based on the criteria. You have to set a lower bound or upper bound. If it is for the minimum, then you have to set a lower bound. If it is for maximum as a criteria, then you have to set as a upper bound. So here criteria is what? Shortest. Shortest means what? Minimum. So that's why first you have to set a lower bound here. So for setting this LB, you are using one equation, that is what? S divided by 2 here. S is what? 2 nearest neighbors for each vertex. For every vertex, you are finding 2 nearest neighbors, and after that you are calculating the distances, and what are the distance you will get? No, that one you will divide by 2, and that result you are taking as a LB here. Let's see with one example. This is the given graph and A, B, C, D, E are what? Now you are representing your cities in the form of the vertexes here. And this edge cost represents what? It is the distance here. So now first I have to find a LB here. For every vertex I have to find 2 nearest neighbors. 2 nearest neighbors means among the A. For example, if I take the A, for the A, how many nearest neighbors are there? For A, B is neighbor, direct connection if it is there. A to B, direct edge if it is connected, then you call this B is the neighbor for A. In the same way, A to D, D is also neighbor. And also in the same way, C is also neighbor. And E is also neighbor, but the nearest means edge cost you have to check. So if you take edge cost is 8, C 1 and D 5 and B 3 here. So among these 4 neighbors, nearest means edge cost with minimum weight. So C is having the edge cost as a 1 and B is and the edge cost as a 3 here. Then these two are 2 nearest neighbor for A. That's why here I taken as what? AC plus AB. AC is edge. It connects A and C vertex. And AB is the edge and it connects AB. Okay. So what is the edge cost for AC? That is 1 and AB edge cost is 3 here. In the same way for B, 3 and 6. 3 means BA. That's why BA plus BC. 6, CA plus CE. For the C, 2 nearest neighbors are A and E and edge cost is 1 plus 2. And for D, E and C are nearest neighbors and edge cost are what now it is? 4 and 3, that is what? 3 plus 4. And E. For E also, EC and ED are the nearest neighbors 2 and 3. 2, 3. So now if you add up, you will get the result as a 28. 28 divided by 2, then you will get as a 14. This is your LB. Okay, is it clear? So for every vertex, 2 nearest neighbors you have to select here. Nearest means what? That edge cost must be minimum here. Okay, is it clear? Okay. Next I'll start visiting the vertex. Which vertex I have to visit now? I'll take A as a source. From this vertex, I'll start visiting the remaining all vertices. So now from the A, I can visit B, and I can visit C, and I can visit D, and I can also visit E here. I don't know which vertex, if I select to visit next, I'll get the shortest route here. That's why I have to check all the possibilities. One is after A, I may select B, or I may select D to visit, or I may select visit E here. I'm not considering this AC because what I am having one criteria. What is that criteria? First compulsory I have to visit B. After visiting B only I can visit vertex C. Okay, that is the criteria. Due to that reason I am not considering this AC now. At present I am not considering that one. Okay. Next is, at present I am not considering this one. So next I have to check for this AB. Meaning of this one is what? Now I am visiting this AB vertex. Then one vertex is, one neighbor for A is fixed here. Okay, it may be nearest or may not, but it is fixed. That's why you have to take AB, it is fixed. And for B also A is fixed. That A vertex may be nearest or may not, but that vertex is fixed here. So that's why AB and BA, these are the two edges are fixed. Next you have to follow the same procedure. What is that? For the A, next one more nearest neighbor you have to select. So AB, it is fixed. It may be small or may not, but it is fixed. Next one more nearest is AC. For BA, so for B also BA is fixed. Nearest one is what? BC here. Okay. So next BC. Next is for C, both the vertices you have to select as a nearest. For D also same, and for E also it is same. Only these two you have to check as a fixed. AB, meaning of that one is what it is. For A, B vertex is fixed, and for B, A vertex is fixed. And next you write the edge cost, and if you are add up, you will get the total result as a 28. 28 divided by 2, that is equal to 14. Next is AD. Meaning of this one is what? For A, this neighbor vertex is fixed. It may be nearest or may not. Same thing for D, this neighbor is fixed here. Okay. So AD and DA are fixed. Next for remaining, you have to check the nearest neighbor. One neighbor it is fixed for A, that is D. The next vertex you have to check as a nearest, that is AC. For B, both nearest. For C, two nearest. For D, only one nearest, that is DA, because DA is fixed. The same thing for C, two nearest neighbors you have to check here. So after calculating, after substituting the edge cost of these vertices, so you will get the result as a 31 divided by 2, that is equal to 16. AC means here it is 1. And AD means what it is? AD is 5 here. 1 plus 5 is what? 6 here. Okay. In the same way, for the D, E is 3. And next one is DA, it is 5. 3 plus 5 is. So this may be nearest or may not, but that one you have to consider compulsory. Here AE means what it is? For A, E vertex is fixed. Okay. Next for E, A vertex is fixed here. So remaining you have to select the nearest neighbors. So for A, one vertex is fixed. Next one you have to select the nearest one. So that is AC. For B, two nearest neighbors. For C, two nearest neighbors. And for D, two nearest neighbors. But for E, one nearest neighbor, and A, it is fixed. It may be nearest or may not, but you have to consider that one as a fixed here. So now you substitute the values in the place of this edges. AC means what it is? 1. And AE means what it is? AE, it is 8. In the same way, for all the edges, you place the edge cost of the edges. If you are add up, then you will get the total cost as a 38. 38 divided by 2, it is what? 19 here. Is it clear now? AB means for A vertex, B is fixed. For B vertex, A is fixed. Remaining, you have to select the nearest neighbor. AD, for A, D is fixed, and for D, A is fixed. Remaining, two nearest neighbors. For A, E is fixed, and for E, this vertex is fixed. For remaining, two nearest neighbors you have to calculate. After calculating the LBs, so now you have to check. Okay. So which one is at the lowest LB here? 14, 16 and 19. Lowest is what it is? 14. So then I am not considering this one and I am not considering this one. Now I am considering only this part and I'll continue with the next part. So meaning of this one is what? Now A to B. I visited next city, that is B. Now my aim is what? From B to remaining all vertices I have to find the shortest path here. So now for B, for B, after B I can visit C, I can visit D and I can visit E. Three possibilities are there. So that's why I have to check the three possibilities. After AB, it may be next vertex is C, or next vertex may be D, or next vertex may be E here. Okay, so three possibilities I have to check. So for checking that, once again I have to take as a LB here. So now here for A, B vertex is fixed. Okay, among two nearest neighbor, one neighbor is fixed, that is AB is fixed. In the same way, for B vertex, C is fixed. Okay, BC it is fixed. And for the C vertex, B is fixed here. BC it is fixed. So now for A, B is fixed, for B, C is fixed, and for C, B is fixed. So remaining, once again you have to check the nearest neighbor. AC plus AB. Okay, so AB is fixed, one nearest neighbor is C here. BC is fixed, one nearest neighbor is A here. BC is fixed, one nearest neighbor is A here. For D, two nearest neighbor. For E, two nearest neighbor. So next you substitute the edge cost of these edges, then you find out the sum, you will get the edge cost total as a 32. 32 divided by 2, it is equal to 16. In the same way, for this one, meaning of this one is what? For A, B neighbor is fixed. For B, D neighbor is fixed. For D, B neighbor is fixed. Remaining nearest one you have to select here. That's why for A, B is fixed, AB edge is fixed. And next one is nearest neighbor. For B, BD edge is fixed. Nearest one is BA. C, two nearest neighbor. For D, DB is fixed. One vertex as a fixed and next one you select as a D. Next EC, ED, two nearest neighbor here. So now after that you substitute the edge cost of the each edges and you calculate the total cost. That one is 32. 32 divided by 2 is 16. Now here what now you have to tell now? For A, which edge is fixed, which vertex is fixed now? B is fixed. For B, E is fixed. And for E, B is fixed. Next, remaining, for remaining you have to select the nearest one. For AB fixed, next nearest one is AC. B is fixed, next nearest is BA. For C, two nearest neighbor. For D, there is no fixed vertex, that's why two nearest neighbor. And for E, one vertex is fixed, that is B is fixed. So that edge cost, it may be minimum or may not, you have to consider here. Fixed meaning is like that only. Next one is remaining one, you have to select as a nearest one. So if you are substitute, you will get the edge cost as what? 37. 37 divided by 2 it is 19 here. You will round up, you will get as a 19 here. So this is the second step here. Now thing is what here? You got the LB. So now if you are take as a, after visiting B, next if I visit C, then I will get the LB as a 16. D if visit, then also I will get the edge cost, the LB as a 16 here. But if I choose E, then I will get the LB as a 19. This one I am not considering. I have to consider which, okay, LB is minimum. That one only I have to consider now. But here I am getting the two LBs are same here. Then I have to check the both the possibilities here. Okay, in this situation you have to check the both. If any one, then you continue that part, you discard the remaining part. But in this situation, you have to find the both the possibilities. So now A, B, C is fixed. Okay, meaning of this one is A and B and C also you visited. Now how many vertices are left as unvisited now? D and E here. So now after visiting C, you may visit next vertex as a D or you may visit next vertex as a E here. So if you visit E next, then how many vertex are left as now unvisited? Only one vertex, that is D. After visiting the last vertex, you have to go back to source from where you have started, that is the DA here. If it is D is visited, then which vertex is last as unvisited? E here. Then from E to A, whether positive path is there or not, you have to check here. That's why I taken like this. So here, not necessary to go for finding the LB. Directly you find the path here. Meaning of this one is what? L. L is the shortest length. Okay. A to B, B to C, C to D. Now A to, meaning of that one is what? A to B. A to B distance is what? 3. Next B to C. B to C distance is what it is? 6. Next is C to D. C to D distance is what? 4 here. Next D to E. D to E distance is what? 3. Last is E to A, 8. So now this is your path, and based on that edge you, okay, edge cost of those path you have to specify here. So now if you add up, you will get the 24. So now here I am not finding the LB, I am finding the length. That's why I am taking the path length directly here. If I select this path, then I got the, okay, length of the path is 24. If I select this path, then meaning of that one is what? A to B, B to C, C to E, E to D and D to A. So now what is the cost I got now? 19 it is. Okay. So now in the place of this one, if I visit the, okay, instead of visiting C, if I visit after B, if I visit the next city as a D, then remaining are what now? C and E here. Okay. That one also I have to check here. A to B, B to D, D to C, C to E and A. Same thing. A to B, B to D, D to E, E to C and C to A. Okay. So if you are substitute those values, you will get as a cost as a 20, length as a 24 and 16 here. So these are the possible paths. Okay. These are the 4 possible paths you are getting to visit. Okay. Visit the all the cities here. So among these 4, which one is having the shortest length, that one you have to consider as a optimal solution. So 24, 19, 24 and 16. Which one is optimal now? Minimum length. Minimum length is what? This one. 16 is the minimum. Yes, this is your optimal 2. And this is your shortest path here. Okay, or shortest 2. What is that path? First you have to visit A. Sorry, from A only you have to start. First you have to visit B. After visiting B, next city is D. Next E. Next C. And C to A. This is the shortest tour to visit the all the cities. This is the what you call as a solution for traveling salesperson problem using branch and bound design strategy. Okay, same thing it is explained in the form of this graph here. And this graph, what do you call? This graph only you call as a state space tree. Usually in branch and bound and in the in backtracking, you will get the solution with the help of state space tree here. Is it clear now? Okay. Thank you.